Okay, so in this question here, we want the acceleration of the train when t equals 10 seconds and when t is 420 seconds. Now let's focus on the t equals 10 to start with, okay? The t equals 10 is here, isn't it? Okay, and that's when the train is accelerating, you can see here, from a velocity of 5 to a velocity of 20. So what we can do is work out the acceleration during this whole period, okay? If we work out the acceleration during this whole period, then we've got the acceleration when its time is 10, because the acceleration doesn't change. It's got the same gradient here, okay? So we could use Suvat. We could say, look, when u there is 5, okay, this sort of starting speed when we pick this journey up, and it gets to a speed of 20 in a time period of 30 seconds. So over 30 seconds, it goes from 5 meters per second to 20 meters per second. So if we use then v equals u plus at, okay, well, v is 20, u is 5, a we want to find out, and t is 30, okay. So take that 5 over the other side, okay, we get minus 5, and then that equals then to 30a, and then that becomes 15, divide by 30 then is equal to a. So my acceleration is 0.5 meters per second squared. Now that's one way of doing it. You could have simply looked at the gradient from the graph, yeah, because remember, the gradient is the acceleration, yeah, you've got to remember that. So you could have done it that way, okay. The alternative approach is to look at the gradient. Okay, remember, the gradient is the acceleration, which quite simply is the case because the gradient tells us here how velocity is changing over time, okay, the slope of it, how velocity is increasing, and that's what acceleration is, isn't it? How it's a measure of how velocity changes. So in this case, we've got change in the velocity over the time, okay. So you've got change in velocity, well, it goes from 5 to 20, so that height there is 15. Okay, so 20 take away 5. Divide by then the time, which is 30. So different ways of doing it, right? But you still get the same answer out, okay? By looking at the gradient, you're forming a triangle, and the rise divided by the step. Okay, now when it comes to 420 is there, isn't it, roughly? And you can see there, we've got a flat line, okay? So when you've got a flat line, the gradient is 0, isn't it? So when t is equal to 420, the gradient is 0, because there's no slope. Therefore, the acceleration is 0. It's keeping the same speed, so it's got no acceleration. Part B then, it says find the velocity of the train when t equals 20. So they want us to actually find the velocity here for a specific time. So t is 20. Now t is 20, of course, in this part of the journey, okay. So again, we can apply Suvat for this part of the journey here where it's accelerating, okay. So we know the initial speed is 5, okay, so I can write that down. All right, the initial speed is 5, and we know then the acceleration in that part of the journey is 0.5. Okay, so we want to then get v, again using v equals u plus at. So v will be 5 plus 0.5 times 20. Okay, so if I work that out, it comes out to be 15 meters per second. Again, you could have worked out using the gradient function on the graph there, okay, and work backwards, you still end up with the same speed. Part C then, it says find the distance travelled, okay, between 0 and 480 seconds, the whole distance travelled. Now, of course, what you've got to do here is look at the area under the graph, right? So remember that, right? That's the best way to do that when they give you a graph. The distance travelled is the area under graph, okay, under the graph. So if we look at the areas here, consider this trapezium here as shape, we'll call it A maybe, B there and C there, okay. So we've got a trapezium here. Now ignore my triangle here. We've got a trapezium where these two sides are parallel. Okay, if you turn it around, you'll see the trapezium there, right? where those two sides are parallel. So remember the formula then for a trapezium, this is what you've got to remember, is that, okay? So for A then, right, we've got half A plus B. So going back to my table, my velocity time graph here, A is 5 and B is 20. Okay, so 5 plus 20 times by the height between them. Now the height between them, of course, is 30, that time interval there. Plus then the area of B, okay, which is that there, okay. So we got length times width. So the length is 400 and the width is 20. So 400 times 20. Plus then the area of C, which is a triangle. So the base there is 50. Okay, gap there is 50 and the height is 20. So that'll be 50 times 20 divided by 2. So if we work all that out, we'll actually get the distance. So we'll work it out in stages maybe. Okay. So that bit there is 375. Okay. That bit there is 8,000. And that bit there is 500. So I add that then together, I'll get 8,875 meters.